Hey everyone, welcome back to another genetics video. So what we're going to do today is we're going to go over how to analyze pedigrees the fastest way possible for you to get a mode of transmission answer. So pedigrees is something that a lot of students struggle with, and rightfully so, because you have a massive pedigree that you have to look at, and then you have to figure out from a lot of individuals, figure out if it's an autosomal gene or if it's a sex-linked gene, and then figure out the different kinds between them. So it can be very difficult, especially if you don't have a lot of time on your exam and you're looking at this. It can get confusing. Okay? So the first thing about pedigrees that you have to know is the simple arrangement between the males and the females. The females are typically referred to as circles because females are curvy. So that's an easy way how you can remember this. And then males are squares. So these will be males. So if you ever get confused on an exam, which one's a female, which one's a male, the female will be a circle because they're curvy. Okay, from here, our objective by the end of the video is to find a way how we can figure out if a certain pedigree is autosomal versus sex linkage, and then what kind of class of these genes is it? Is it an autosomal recessive gene, or is it an autosomal dominant trait? If it's Y linkage, X-linked dominant or X-linked recessive. So to begin with, for autosomal genes, the males to female ratio should be the exact same, or not exact same, but closer together for autosomal traits. So that'll be a hint for you to know that if a particular pedigree has an autosomal trait associated with it. Okay. Then, how do we figure out if we have a autosomal dominant trait from that? So the typical way how you can do this is to determine if there is a trait for autosomal dominancy versus autosomal recessive. The way how autosomal recessive works is that, let's say we have an individual, a male and a female, they're crossed together, and they end up with an individual that is affected. And the way how we denote affected individuals is by marking them off, by coloring them in. So the marker for autosomal recessive is something like this, where we have two individuals that are not affected by a trait, and they have an affected son or daughter. So that'll be a typical marker of autosomal recessiveness, because let's say that this trait wasn't in fact due to autosomal recessive but autosomal dominant. So let's say instead we said that the son over here is big A, or big A, little a. In order for you to get big A, little a, you have to get the big A somewhere. But because both of these individuals in our hypothetical example aren't big A, therefore this marker does not work for autosomal dominancy. But however, let's say we're trying to figure out if this is autosomal recessive, and let's say that these two individuals are heterozygous for the gene, so therefore they're giving both of their little a's to this individual. So this is a marker that you want to look for to determine if an individual is autosomal recessive. Okay, so it's pretty easy for that. But then the autosomal dominant marker is basically flipped. So what you can say for the autosomal dominant one is that, let's say we have a male and a female crossed together. They have the same son. But now we're going to say that the male and female are affected with the trait, and their son is not affected with the trait at all. So this will be a marker for autosomal dominancy. The reason why this works is, let's say these individuals are big A, little a. And this individual is recessive. So what you're going to end up with, this individual will be little a, little a. And this will be a marker to show that this trait is in fact a autosomal dominant marker. Okay? So we can go over a couple of practice problems as we go on, but this is something that you want to look for, especially for if you're trying to figure out if it's autosomal dominant versus autosomal recessive. Now the easiest one to figure out from all the different options is Y linkage. The thing with Y linkage is that you always have an affected dad, and all of his sons are always affected, and all of their sons are always affected as well. The reason why this is because males only have a single Y chromosome, so that same Y chromosome is being passed on to this son, and then that same Y chromosome is also passed on to their other sons right here. So that one is probably the easiest one to figure out, probably the quickest one as well. The next one is X-linked dominant. The X-linked dominant marker is a pretty interesting one where you have an affected son and what's going to happen is that this affected son will have all affected females. The reason why this works is, let's say that X big A is the dominant marker here. This son has only one big XA or X big A and a Y. So all of his females are going to get the X chromosome from their father, and they're all going to be X big A. So they're all going to contain a chromosome that is big X big A from their father. So they're all going to have the dominant trait, dominant phenotype for that one. And then the last one, X-linked recessive. X-linked recessive is the opposite, where you have an affected female. You have a father, and all of his sons are affected. And this will be a marker for X-linked recessive. The reason why this works is because, let's say that this female has X little a, because males only have one X chromosome, the only X that they're gonna always get is from their mom. So the mom will always give this X little a to all of her sons. So therefore, all of her sons will be X little a Y, X little a Y, and X little a Y. Cool. And that's basically what you can use to figure out if a particular trait is these particular these things that you're looking for. Just to note that also in autosomal dominancy, for this one you're gonna see something like all offspring have an affected parent. And then over here for autosomal recessiveness, you're essentially skipping some generations. And we're going to go over some clear-cut examples on the bottom for y'all to understand. For the male to female ratio, that is going to be different between the different types of possibilities. With the males, or with the Y linkage, you're always going to have a 100% males affected. For the X-linked dominancy, what you're going to see is, looking at this example right here that we have, you're going to see more affected females, more females than males. And then the opposite is true for X-linked recessive. You're going to see more males than females. Okay? And that's basically that's the tools that you can use to figure out what kind of a mode of inheritance is a pedigree. So let's do some practice problems. And what I recommend doing for a lot of students is first try to figure out if there's sex linkage or if there isn't, okay? So what I recommend students doing first is the easiest one, Y linkage. Figure out if there's Y linkage or not, okay? So the first one that we have is we have an affected grandfather. His son is affected, and his son is affected too. And then after this point, all of their sons are also affected as well, as you can see on the right side as well. So therefore, this one is Y linkage. So this is Y linked right here. So like I said, pretty easy. You don't need to put a lot of effort into figuring this one out. So hopefully that one kind of made sense. The next one, because we have affected females here, not Y linkage, so we can write that down, not Y linked. Okay, so the next thing that you want to figure out, is this trait is this trait X-linked dominant or X-linked recessive? First of all, let's look at an individual like this one right here, this affected female. If we said that this affected female was X-linked recessive, she should be X little a, X little a. Therefore, she would have to give her recessive X chromosome to all of her sons, and all of her sons would have an X recessive chromosome. So because of this, it cannot be X-linked recessive. So it's not X-linked recessive. So now what we need to do is we need to figure out if this trait is X-linked dominant. So let's look at this individual over here. Let's say if this individual is X-linked dominant, he would have to be X big D, or oops, wrong gene, X big A, Y. So every female would have to have this X big A allele, and he would give it to this female. But obviously she is not affected, so therefore this trait is not also dominant. So it's not dominant. And now it's basically us trying to figure out if it's an autosomal recessive or an autosomal dominant gene. Okay? Cool. And another thing that you can do before we even begin with anything else is you can count the males to female ratio. So you have 1 male, 2 male, 3 male, 4 male, 5 male, 6, 7. So 7 males, and you have 1, 2, 3, 4, 5 to 5 females. So in this situation, they're pretty close together. But keep in mind, we just have a very, very small sample size. So this difference may have been just attributed just to luck. Okay? So now what we can do is we can figure out if it's autosomal dominant or autosomal recessive. Now, remember what I want you to look for is I want you to look for a particular section where you have either two individuals that are not highlighted and they give you an individual that is affected. That will prove that it's autosomal recessive. So what you're going to look for is you're going to look for something like this. And if we get an individual that if we get an individual that is marked like this, it's most likely going to be an autosomal recessive trait. And then if we have a situation like this where we have two individuals that are affected crossed together and you get a non-affected individual, then that most likely is an autosomal dominant marker. And now that I look at this, most likely I've probably made a mistake on this problem. This individual should be marked off. Apologies for that. But basically, what you would look for is that kind of a situation where you will look for that situation. If this individual wasn't marked off and you had an individual that is affected here, that'll be an autosomal recessive trait. But for this particular problem, it doesn't really make sense for it to be that. The reason why is that you have every single individual here that is affected has an affected father or a mother too. So apologies for that. You would just have to look for that particular clue. But yes, so this is a autosomal dominant trait. So let's try this one out now. First of all, is it Y linkage? No. It's not Y linkage because we have an affected female here. So it's not that one. Is it X-linked dominant or is it X-linked recessive? So what we have here, we have 1, 2, 3, 4, 5 males to 1, 2, 2 females. Okay. So we're kind of basically leaning on it, since the difference is around 3, we're kind of leaning on into it being a sex-linked gene, but let's keep going forward. Let's assume that this particular person let's assume that this is an individual that is X-linked dominant, so X big A, Y. So this X big A has to be given to all of his females, his daughters. So this one's given, but this one isn't. So therefore, it cannot be given, or it cannot be X-linked dominant. Cannot be X-linked dominant. Okay? And then let's try to figure out if it's X-linked recessive. If it's X-linked recessive right here, or we're going to look at this female first. If it's X-linked recessive, she would have to be X little a, and that X little a would have to be given to all of her offspring. So it could be that this particular trait is due to X recessiveness. Okay. And since we have more males to females affected, it's more than likely than not that this particular trait is passed on through, this particular trait is a X-linked recessive trait. Another thing that you can also look at is you can try to make it sense by modifying the genotypes of these individuals. So let's say if we said that this particular trait is due to X-linked recessiveness. So how are we getting this individual that is affected here? So the way how we're getting that individual is that this female had to have been X big A, X little a, and then she's giving her X little a. She's a carrier and she's giving that to her son as well. So hopefully that one kind of made sense. So the next one what we can try is same thing. We have 1, 2, 3, 4, 4 males, 1, 2, 3, 4, 5, 5 females. So we're kind of on the closer side to it being autosomal because they're kind of the same number. So now what we need to do is we need to figure out if it's not Y linkage, right? So it's not Y linkage. Now we need to figure out if it's an X-linked trait. So first of all, what we're going to do is we're going to look at this individual over here. Let's say this trait is due to X-linked recessiveness. So X little a, Y. Like I said before, this X little a had to have been given to all of his daughters, but it hasn't. So therefore this trait is not X-linked recessive. Now what we can do is we can do the exact same thing, but for the other female on the other side. Let's say that our trait is due to X-linked dominancy. So X big A, X. Or apologies, this would have to be, this one would have to be X big A, this one would have to be X little a. Yeah, so if we said that this trait is over here on the left is due to X-linked dominancy, then all of his sons or all of his daughters had to have been affected with that big XA, big gene. On the other hand, if you look on the right, this will be a marker for X-linked recessiveness. If she was X-linked recessive, she would have to give this X little a to all of her sons, which she hasn't. So it's not any of the X linkage modes of inheritance. So this has to be an autosomal mode of inheritance. So let's try to figure out which autosomal mode of inheritance it is. So what you're going to do is you're going to look for something like this. So right here what we have is two individuals that are not affected, and they're crossed together to generate an individual that is affected here. So if you look back on our cheat sheet, if you have a situation where you have something like this, where two parents are not affected and they're giving rise to an affected offspring, this is a marker that this particular mode of inheritance is through an autosomal recessiveness. And that'll be the answer for that one. Pretty simple. Next, what you need to do for this one, same thing. You have 3 males to 1 female. It's not Y linkage, right? Because we have an affected female. So now you need to figure out if this particular trait is due to X linkage. So let's try to figure out if it's X-linked dominant. So this particular male would have to be X big A, Y. So this X big A would have to be given to all of his daughters, right? So she got one, and then this female would have to get one, but she doesn't. So therefore, it's not X-linked dominant. Same thing, we can do the exact same thing, but over here. Let's say that this female is X little a, X little a. She would have to give her X little a to all of her sons, which she doesn't. So therefore, this particular pedigree does not show X-linked recessive. Okay. So now what we need to do is we need to figure out if this is autosomal recessive or if this is autosomal dominant. Now with this one in particular, because we don't have a lot of individuals affected with this trait, the most probable assumption that we have here is that this is an autosomal dominant trait. The reason why this is autosomal dominant is essentially because of the rule that I mentioned before. where all offspring have an affected parent. We don't have an instance where we can have a cheat sheet like how we did before, but this would have to be something that you would have to make an assumption on, especially given the data that we have. But that's how you do these problems. It's actually pretty simple to do these. If you have a question on your exam that has multiple different possibilities, like let's say we have a female and she's divided up in half, and then on your problem it will specify that the left side is for one gene and the right side will be for another trait. And a lot of people get confused on those ones as well. The way how you can do these problems is you can just simply ignore one of the traits and do one trait at a time, like how I always preach. But that's all you have to do. So hopefully this helped. Please leave a comment if you still have any questions. But yeah, that's it.